All right, AP Stats, this is your feedback for reading section 10.1. I'd like to look at your discussion board. Suppose I bring 2 bags of colored goldfish crackers to class. One bag is 25% red crackers, the other bag is 35% red crackers. Each bag contains more than 500 crackers, so with that statement, they're going to guarantee the 10% rule, which makes sure that the samples are independent from one another, because notice our sample size is 50. If it was any more than that, then that would violate the 10% rule, and the sampling would not be independent. Um, so as we look at this, they're taking sample p hats of size 50 and sample size p hats of size 40. And one way to easily simulate this is at a website called Rossmann-Chance Applet Collection. Just Google that if you're wanting to do this. But what I can do is actually simulate a bunch of these. So say that 25% of the population is orange, and I have a sample size of 40, and it will actually simulate that for us in a rather neat little animation here. If I take off the animation, I can do many of these, and what you're looking at is my first sample is 27%, my second sample is 17%, my third sample is 30%, and I can do that many times. And I did that for you over here. Well, I didn't do it many times, I did it 15 times. So this first column, the one on the left, is from bag 1. The second column is from bag 2. And this third column helps us understand what it means to take the difference of two sampling distribution proportions. So for the difference, I just subtracted each sample proportion from each other. So this first one is 0.2 minus 0.24 is negative 0.04. And you can see that most, if not all of these are negative, because it's more than likely that bag 1 will have a smaller proportion because bag 1 only has 25% colored red, while bag 2 has 35%. And sure enough, in all my samples, I did get a negative difference. Okay, so to look at that graphically, I can open up my Desmos, and what you're looking at here is the first bag. So this first bag has the 15 samples from the 25%, and then let me throw on the second bag. Those are the green ones. Those are greater proportions because that's from the 35%. And then if I show my difference distribution, it looks like this, okay? So the one thing I want you to recognize right away is that of these three distributions, the green, the blue, and the purple has more variability. And we talked about this in sampling distributions where we have to add the variance and square root them. And that's what I'll show you in the end of this video. But sure enough, the difference of the proportions do have more variability, and we can actually calculate that as a standard deviation. Another important question to ask is, are these distributions normalish? Are they approximately normal? And the answer is yes. And that's because of the NP rule. For the blue distribution, we would have 25% times 50 is more than 10. For the green distribution, we'd have 35% times 40 is more than 10. So these will be a normal distribution approximately, which implies that the difference of these will also have a normal distribution. And so that's a big part of this. And so let's look at some really good responses. Here was one right here. Wow, I'm going to give a shout out to Kiana. She has really been doing well with these discussion boards. And so I need to show this off. And hopefully this is something that you do. I hope you revisit the discussion boards after people have posted to compare your answers to others and maybe fill some gaps. But what she does first is for a difference of sampling distributions to be normal, then we have to do 4 calculations. We have to show the success and failure counts for each proportion. The green, or the bag with the 25% and the bag with 35% is more than 10. If any of those are violated, then we wouldn't have a normal distribution with the difference. And so here it is. We want to square the standard deviations. So when we square the standard deviations, the square root goes away. Normally this was the square root of n but squaring that produces the square root of n squared, and I'm going to add these two variances and then square root it, and that will give me the standard deviation of the sampling distribution of the difference. And this is something that we'll definitely talk about more in the live sessions Thursday and Friday.